Dear students, this video lecture is about interaction of energy with the atmosphere. There are different types of interactions among the atmosphere and the emitted radiation. The first event is scattering. Scattering occurs when the particles of large gas molecules present in the atmosphere interact with and cause the electromagnetic radiation to be reflected from its original path. How much scattering takes place depends on the several factors, including the wavelength of the radiation, the abundance of the particles or gases, and the distance the radiation travels through the atmosphere. There are three types of important scattering. The Rayleigh scattering, it occurs when the particles are very small compared to the wavelength of the radiation. The figure indicates the Rayleigh scattering. Then absorption. Absorption is the other main mechanism at work when the electromagnetic radiation interacts with the atmosphere. In contrast to scattering, this phenomenon occurs molecules in the atmosphere to absorb energy at various wavelengths. Ozone, carbon dioxide, and water vapor are the three main atmospheric constituents which absorb the radiation. Next one is Mie scattering. The Mie scattering occurs when the particles are just about the same size of the wavelength of the radiation. Dust, pollen, smoke, and water vapor are the common causes of Mie scattering, which tends to affect the longer wavelength than those affected by the Rayleigh scattering. Then atmospheric windows. The important term in the interaction of energy in the atmosphere is atmospheric windows. It is like our same residential windows which allow some air inside the rooms. The same thing happening in the atmospheric windows. The atmospheric windows allows some wavelength energies through them. That is called atmospheric windows. Okay. The atmospheric windows of different wavelengths is given in the figure. UV, visible, infrared. How the energy is interacted. This is the spectral reflectance curve for vegetation, water, and soil. Based on the reflectance value, the graph was drawn. Okay, this is the table, shows the atmospheric scatter in orders of importance. Rayleigh, Mie, non-selective, and Raman scattering. This is the basic for remote sensing data occurrence.